In this video, we are going to solve the problems of exercise 6.3 of NCERT textbook of mathematics class 9. Okay. Before we solve the problems of this exercise, we must know the criteria of similarity of triangles. Suppose we have two triangles ABC and PQR. Okay. So, if the three sides of this triangle and all the three sides of this triangle are in the same ratio, AB by PQ equal to suppose BQ by CR, BC by QR and AC by PR, then these two triangles are similar according to SSS. Okay. And next criteria is side angle side. Suppose we have any two pair of sides of these two triangles are in the same ratio. Suppose AB by PQ equal to AC by PR, and angle between these two pairs are also equal. Suppose angle A equal to angle P, then according to side angle side, these two triangles will be similar. And the third one, okay, and the third one is angle angle angle, that is represented by AAA. Okay, if all the three angles of one triangle is are equal to all the three angles of this triangle. Okay, three angles of these triangles are equal to corresponding three angles of this triangle, then these two are similar by angle angle angle, that is AAA. Or instead of showing all the three angles are equal, if we show any two pair of angles, suppose angle A equal to angle P and angle B equal to angle Q, then also we can say they are similar, because if two angles of this triangle are equal to two triangles of if any two angles, if two angles, suppose A equal to P and Q equal to R, okay, any two angles of this triangle are equal to any two angles of this triangle PQR, then their third angles will be obviously equal. Okay, so that's why two pair of angles, that means this criteria of angle angle only, that is angle angle. So we are showing two angles of this triangle and two angles of this triangles are equal. Okay, so that is also sufficient. Okay, so these are the three criteria. Now, using symbol we can write these two triangles. Triangle ABC similar to triangle, we cannot write here PQR, because you see SQR is 2 times of AB and PR is 2 times of BC. So QR is corresponding side of AB. Okay, and the vertex opposite to QR is P and the vertex opposite to AB is C. Okay, so that's why C and P are corresponding vertices. Okay, so we can write C and P are corresponding vertices. Okay, then you see A is opposite to BC. Okay, this vertex A is opposite to BC. Okay, let me use another color. A is opposite to BC, and here 2 times of BC is PR and opposite to PR the vertex is Q. Okay, vertex Q is opposite to PR, so A is corresponding to Q. So A is written first, so Q must be written first. Then again we have got that here you see opposite to AB there is C, and 2 times of AB is QR and opposite to QR there is P. That's why P is corresponding to C. So C is written at the end, so P should be written at the end, and here B is corresponding to what? R. Okay, here B is corresponding to R, so R should be written at middle as B is written at middle. Okay, so that's how we can write, and the criteria used here is side side side. Okay, that's how we can show these these pairs of triangles are also similar. Okay, so now let me show you the next pair. Now, using symbol we can write these two triangles. Triangle ABC similar to triangle, we cannot write here PQR, because you see SQR is 2 times of AB and PR is 2 times of BC. So QR is corresponding side of AB. Okay, and the vertex opposite to QR is P and the vertex opposite to AB is C. Okay, so that's why C and P are corresponding vertices. Okay, so we can write C and P are corresponding vertices. Okay, then you see A is opposite to BC. Okay, this vertex A is opposite to BC. Okay, let me use another color. A is opposite to BC, and here 2 times of BC is PR, and opposite to PR the vertex is Q. Okay, vertex Q is opposite to PR, so A is corresponding to Q. So A is written first, so Q must be written first. Then again we have got that here you see opposite to AB there is C, and 2 times of AB is QR, and opposite to QR there is P. That's why P is corresponding to C. So C is written at the end, so P should be written at the end, and here B is corresponding to what? R. Okay, here B is corresponding to R, so R should be written at middle as B is written at middle. Okay, so that's how we can write, and the criteria used here is side side side. Okay, that's how we can show these pairs of triangles are also similar. Okay, so now let me show you the next pair. Now you see in this pair this side DF is 2 times of LP and the side PE is 2 times of MP, but 5 is not 2 times of 2.7, that is EF is not 2 times of ML. Now here you see these two sides MP by DE and LP by DF. So these two ratios are equal, but ratio of LM and EF are not equal. That's why these two triangles are not similar. Okay, so now let's move on to the next. Okay, here you see ratio of these two sides is half. 2.5 by 5 is half, so MN by PQ is half. Then ML by QR, that is 5/10, that is also half, and angle between these two sides whose ratios are equal, that means ratio of ML and QR equal to ratio of MN and PQ are equal, and angle between them are also equal. That's why according to side angle side, these two triangles are similar. Okay, so how to determine the corresponding parts? Here you see, so we have to write triangle M and L similar to triangle. Now angle M is equal to angle Q, so corresponding to M is Q. Okay, Q is corresponding to M. Okay, then now you see, we have taken ratio between MN and PQ. Okay, and vertex opposite to MN is L, and vertex opposite to PQ is R. So L is corresponding to R. So L is written at the end, so R should be written at the end. Then remaining vertex is P. P should be written here. Okay, so that's how we can write these two are similar by the criteria side angle side. Okay, here you see, in this pair EF is 2 times of BC and DF is 2 times of AB. Okay, that means we can say AB by DF is equal to BC by EF. Okay, 3/6 is half, and 2.5 by 5 also half. Okay, but here you see, this angle 80 degree, which is a measure of angle F, is equal to angle A. Okay, as we have taken the ratio between these two sides equal to ratio between these two sides. Okay, but this angle is not equal to this angle. Okay, so here you see, we have taken ratio of BC and EF. Okay, BC and EF. Okay, and then we have taken AB and DF. But here you see, angle F is equal to angle A, but to be similar, this angle F should have been equal to B, but it is not equal to B, it is equal to A. That's why these two are not similar. Okay, now this is the last pair of triangles. Okay, here you see, so it is not clear here. Okay, so this angle R is 30 here. Okay, angle Q is 80, angle E is 80 here, angle D is 70. Okay, now you see, in this triangle, if this is 80 and if this is 30, it must be 70. Okay, angle P must be 70, because 70 plus 30, 100, 100 plus 80, 180. We know that sum of the three angles of triangle is 180. So that's why it must be 70 degree. If so, then you can see, here you see, and this angle, if this is 70, this is 80, 70 plus 80, 150, 150 plus 30 is 180. So that's why this is 30. So all the three angles of this triangle are equal to all the three angles of this triangle. Okay, that's why these two are similar. Okay, according to angle criteria. So here you see how to write using symbol. These two are similar. So let me show you. Here you see, if this is 70, angle P is 70, D must be corresponding to P, E must be corresponding to Q, and F must be corresponding to R. So we have to write triangle DEF similar to triangle PQR, and they are similar by the criteria angle. Okay, that's how we can determine a pair of triangles are similar or not. Now let me show how to solve question number 2. Okay, so here you see in this figure triangle ODC similar to OBA. Okay, these two triangles ODC similar to OBA. Okay, and angle BOC 125, this angle is 125, so this is 125. Angle ODC is given, or CDO or ODC same angle 70. So we need to find DOC, that means this triangle, this angle DOC we have to find, and DCO means this angle, and also we need to find OAB, this is OAB. Okay, this angle. So we need to find these three angles. Okay, so let me show you how to solve. Okay, so here you see this is the diagram. So in order to find DOC, this DOC, we have to use the relation BOC plus DOC is equal to 180. It is linear pair. Okay, that means you see, if you in the figure, angle DOC and BOC, okay, these two are supplementary. Okay, as they form a straight line. Here it is linear pair, so that's why here you see BOC is 125, that is given in the question 125. So if BOC is 125, then BOC plus DOC is 180. So DOC must be 180 minus 125, which is equal to 55. Okay, now let's find DCO, this angle. Okay, this angle, we need to find this angle now. Now look at this. If you see the diagram here, so if you see it, then you will observe that this is a triangle, and this is the exterior angle produced when DO is produced. Okay, side DO is produced, and we know that the exterior angle of a triangle produced due to extension of one side is equal to the sum of the opposite interior angles. Okay, so this angle, that is COB or BOC in this triangle. Okay, so BOC is the exterior angle, which must be equal to sum of CDO and OCD or DCO. Okay, sum of these two angles is equal to 125. Now from this relation we can find DCO. Okay, so this is the relation CDO plus DCO is equal to BOC, because BOC is the exterior angle of this triangle ODC. Okay, so here you see CDO is 70, DCO is unknown, and BOC is 125, and from this relation we have got DCO is 55. Again it is given that ODC similar to OBA. Okay, and we need to find now OAB. Okay, angle OAB. So we have already found DOC and DCO, so now we need to find OAB. Okay, now from this relation you see, you can observe C and A are corresponding vertices. Okay, as these two triangles are similar, so therefore their corresponding angles must be equal. That means this angle OAB or BAO must be equal to DCO. So we can write OAB equal to DCO. Okay, DCO we have already got 55, so that's why this is 55. OAB also 55. That means the measure of its angle is 55. Okay, that's how we can solve this. Okay, so hope you understood this. Let me clean this page so that you can note it. Okay, so that's it. Now let us solve question number 3. Okay, so in this question, diagonals AC and BD of a trapezium ABCD with AB parallel CD intersect each other at O using similarity criterion for two triangles, so that OA by OC is equal to OB by OD. Suppose there is a trapezium ABCD. Suppose this is a trapezium ABCD, AB CD, which AB parallel CD. Here AB and CD are parallel, okay, and its diagonals are intersecting each other at O. Okay, if AB and CD parallel, then we need to show OA by OC is equal to OB by OD. Okay, this relation. So let me show you how to solve this. Okay, so here is the solution, question number 3. Okay, so in order to prove this, let us use similarity criterion, because it is given in the question that we need to prove this one using similarity criterion. Okay, it is already given in the question. Okay, so in the last exercise we have proved this one, same question in different way, but now here we need to use similarity criteria. Okay, so let me show you how to solve this. Okay, now AB and CD are parallel, so let us take triangle OAB and OCD. Okay, so those parts, those segments in this ratio are present in these two triangles OA, OC, OB, OD. Okay, so we have taken these two triangles. Now you see, from these two triangles what we will get, these two angles are equal, vertically opposite. We all know that vertically opposite angles are equal. As these two are parallel, so alternate interior angles are also equal. Okay, so we have got in triangle AOB and OCD, AOB equal to OCD, sorry, COD, vertically opposite angles. Then OAB and OCD are alternate interior angles. So what we have shown, so these two angles are vertically opposite, OCD and OAB. Then angle OAB and OCD are alternate interior angles. So if we show two angles of two triangles, okay, two corresponding angles of two triangles are equal, okay, then we don't need to show the third angles of these two triangles. Okay, because two pair of angles are sufficient, okay, if they are equal. So these two triangles are similar according to angle criteria. Okay, now let us solve question number 4. Okay, so in this figure 6.36, QR by QS, QR by QS is equal to QT by PR. Okay, then angle 1 is equal to 2, so angle 1 and angle 2 are equal. Then we need to prove PQS, that is PQS, this triangle, okay, PQS, okay, and TQR, okay, TQR are similar. Okay, these two are similar, that has to be shown here. So let me show you how to solve this. Okay, now let us solve question number 4. Okay, so in this figure 6.36, QR by QS, QR by QS is equal to QT by PR. Okay, then angle 1 is equal to 2, so angle 1 and angle 2 are equal. Then we need to prove PQS, that is PQS, this triangle, okay, PQS, okay, and TQR, okay, TQR are similar. Okay, these two are similar, that has to be shown here. So let me show you how to solve this. Okay, now you see, in order to show these two triangles are similar, I have drawn the two triangles separately here. Here angle 1 is common angle. If we are able to show that TR by TS is equal to QT by QP, then we can say these two are similar by the criteria side, angle, side. Okay, but In this relation QR by QS, as it is given that QR by QS is equal to QT by PR. Okay, that's why here you see we have got in equation number 1 PR is equal to PQ. So let us replace this PR by PQ. Okay, and doing so we have got QR by QS is equal to QT by PQ. Now in these two triangles PQS and QTR, okay, in these two triangles, okay, PQS and QTR, these two triangles, okay, here we have angle 1 is common angle, okay, angle 1 is common angle, and from equation number 2 we have got QR by QS is equal to QT by PQ. So QR by QS is equal to QT by PQ. That's why according to side angle side, these two triangles are similar. That's how we can prove this. Okay, hope you have understood. Let me clean this page so that you can note it. As it is given that QR by QS is equal to QT by PR. Okay, that's why here you see we have got in equation number 1 PR is equal to PQ. So let us replace this PR by PQ. Okay, and doing so we have got QR by QS is equal to QT by PQ. Now in these two triangles PQS and QTR, okay, in these two triangles, okay, PQS and QTR, these two triangles, okay, here we have angle 1 is common angle, okay, angle 1 is common angle, and from equation number 2 we have got QR by QS is equal to QT by PQ. So QR by QS is equal to QT by PQ. That's why according to side angle side, these two triangles are similar. That's how we can prove this. Okay, hope you have understood. Let me clean this page so that you can note it. So here is the solution of question number 4, and these two diagrams are not necessary. Okay, just I have drawn to explain you how to solve this. Okay, but this figure should be drawn. Okay, hope you have understood this. So now note it. Okay, so remaining problems will be discussed in the next video. Okay, thank you for watching.